Okay, so this is question 2 for AQA's June 2013 past paper. Now, in this question, it's all about projectiles, so I do apologise, should have rubbed that off from before. Okay, so we are told that there are two rifles here. I've not drawn them because I can't draw. Rifle A and Rifle B, and both of these dots represent the bullet being shot out of the rifle. We're not told anything about B, apart from the fact obviously it hits the floor. We're told that they both are shot from a height of 1.5 metres above the ground, and that A is fired with an initial horizontal velocity of 430 metres per second. Okay, and the first question asks us to work out the time that the bullets are in the air. Bullet is in the air before it hits the ground, okay? And that's obviously asking about A. But the key thing is to remember for later in the question that they're both in the air for the same amount of time because they're both acted on by gravity. Anyway, okay? So, the equation, the only thing we can work out. Now, you may be going, okay, well, we know the thing that includes, because we're told you, and we're asked to work out the time that it's in the air, well, surely we use the formula x equals ut, because that's got an initial velocity and it's got time. Well, it hasn't got, it's actually got two unknowns. We don't know time and we don't know the horizontal distance covered before it hits the floor. So we can't use that equation. And the only other equation that we have that is to do with displacement, because it's not asking about velocity, is the vertical displacement, which y is equal to a half of gt squared. And now that comes from the Suvat equation, s equals ut plus half at squared, and obviously there's no initial velocity in terms of vertical, so we end up with that equation. But as I said, that's just how you derive it. We put in what we know. So we know y, which is the horizontal displacement, is 1.5 metres. Okay, and that is equal to a half of g, or 4.9, if you want to put it like that, times t squared, okay? So therefore, t is equal to the square root of 1.5 over 4.9, or t is the square root of 1.5 over half times 9.8, okay, same thing. So therefore, if you sub in your value for t, you should get t to be 0.55 seconds. Okay, it does continue, but I would leave that in your calculator's memory, as it will become apparent as we move on. Okay, so now we're asked to work out the horizontal distance covered by A. Okay, so obviously now we know U and we know T. Now what I would do for all kind of these Suvat kind of equations and many questions in physics, apart from the wordy ones, write down what you know. So we know the horizontal displacement, delta y, if you want to call it that, is 1.5 metres. We know the initial velocity, U, because we're considering A, remember, is 430 metres per second. Now you might not need all of this, but it's always good to, just so you don't write not enough, it's always better to write too much than not enough. Okay, so we know U and we've just worked out T to be 0.55 seconds. Now as I said, I would preferably leave that in your calculator's display, or you could just retype it in the equation to work out T, which is just the square root of 1.5 metres over 4.9 metres per second squared. Sub it in wherever you put this T, but as I said, it's up to you. Okay, so we've got y, u and t, okay? Well, what we want to work out is x, the horizontal displacement, so obviously therefore y is discounted. And the only one that links x, u and t together, which is what we currently know, as I said, you could write the value of g, but it'd be pointless. Okay, we know x is equal to ut. Okay, so u being 430 metres per second, and t being 0.55 seconds, which is, because they do model it on a realistic situation, so there's not going to be a time period of 20 seconds before a bullet hits the ground, unless you're you're in Mars or on the moon. In Mars or Mars? Okay, so therefore if you sub that in your calculator, you would get the value for the horizontal displacement, which is, you get 237.8 metres. Now because, these basically, if you're not sure what number of significant figures to round it to, basically it doesn't specify, and in this case it says round it to an appropriate number of significant figures. To many of you may think that's just a giant middle finger to say, haha, we're going to make you lose some marks with significant figure error, because some people would just leave it as that. It's not wrong, but you could take it, you could round it up, okay? So appropriate number significant figures. Well, in both of the bits of data they've given us in terms of the initial speed of the bullet and the height above the ground that it's shot, they're both given to two significant figures. So therefore, you know, we can logically assume that we need to give this to also to two significant figures. So this is exactly what we do. So therefore, if you round this to two significant figures, you'll get the horizontal displacement as 240 metres. Remember, 0 is not a significant figure for obvious reasons. Okay, now the reason I've not kind of rubbed all that out is because, well, you need to write it down, so if you're doing the exam. But this next part is part B. It's just more a theory question that I need to talk you through, really. There's no point in me writing too much of it down. Okay, so we're told, now there's a reason why I've drawn these curves and why B has clearly a smaller horizontal distance than A, because this is what part B is asking. Weirdly enough, part B to do with B. Thought of that one. Anyway, so we're told that rifle B is fired and the bullet emerges with a smaller horizontal velocity than rifle A. Now, if you're one of them people that can't imagine it off your top of your head, then it's just the speed of U, the initial speed of B, is anything less, so X could be, sorry, X is a bad thing to put, don't know, F is less than 430 metres per second. Basically, its initial speed is less than 430, which obviously gives it this smaller horizontal distance covered. Okay, we need to explain why the horizontal distance travelled by bullet B was less than bullet A. Now, it's worth 3 marks, so, I mean, it specifies this in the mark scheme, but you should be able to work from the amount of space I've given you there and the actual 3 marks that it's asking for. It's not as easy to put, well, it's got a smaller speed, so therefore it covers a smaller distance. Well, obviously, that is not acceptable, okay? They allow that as a road into the question, but they wouldn't give you any credit for that at all, okay? And that is because, well, the best way to do it is talking you through. Now, I found this a bit weird when I did the question. I didn't include this in my answers, and you know, even the genius I am, I didn't include this as a starting point. But it looks more and more as I continue to look through this exam that this particular question wants you to start with the phrase or something similar, so word for word, that they both have the exact same. They are both in the same in the air for the same period of time. Sorry, they're both in the air for the same period of time, and that's because we said the displacement of y was half gt squared. Now they're both affected by g. We obviously imagine to be acted on the exact same value of g. Okay, so on the same planet, actually. And obviously they're both from exactly the same height. Now there's some area there, but you know, we'll let them off. We'll assume it's exactly the same. Okay. So therefore, if you work this out for A, we could have. This is the same for both A and B. They're both in the air for 0.55 seconds. But how could that possibly be when one clearly has a lower speed? Well, you've got to remember that speed that is given is the horizontal speed. It's not the vertical speed. The vertical speed, and therefore the acceleration of the vertical speed, is exactly the same for both A and bullet B. Now, if they're both falling at the same rate, they may not be moving across at the same rate, they'll be in the air for the same amount of time, okay? Just that in that time, A obviously is moving faster horizontally, okay? Therefore it's going to cover more horizontal distance. So basically, as I said, hopefully you get that, but really if we're moving, if we're pushing an object along a flat plane, this is just an example, just trying to get you thinking about it if you couldn't understand that. If we're pushing it along a horizontal plane, okay, and the longer time we have to push it, if we're given a given time frame to push it, okay, along the floor, the longer the time we have, if we're given a specific time to push it along the floor, the faster we push it, the more distance it will move, okay, horizontally. Now, in that case, it's not falling, okay, but we're just considering the horizontal velocity. Whereas in this, obviously, we're considering the vertical velocity, but the vertical velocity is the same, and therefore they're in the air for the same amount of time because they're both being acted on by the same value of g, or acceleration. Therefore, the time that they're in is the same, and it comes back to that thing I said about pushing it along the horizontal plane. And because A is being pushed along faster, I never say it's falling as well, but this is just to kind of get rid of your mind of the vertical velocity, okay? If it's moving faster, then obviously it's going to cause go through more distance. But a key sentence you need to say at the start is you have the same vertical velocity, so they're initial vertical velocity. So therefore, as they're both being shot from the same height, you could drop that equation in. But as I said, something else to put in if you're not 100% sure. So therefore, they're in the air for the same amount of time. And then you would refer to this x equals ut, and you say, okay, well, as we know, the horizontal distance is calculated by x equals ut, where u is the initial speed and t is the time. And then you go on to say, because I've just mentioned that t is the same for both bullet A and bullet B, therefore we can assume t to be constant for both, which is pretty much what I've just said. And therefore the only thing that will change the horizontal displacement of the two bullets is the initial speed. Now we know the initial speed of B is less than the initial speed of A. So therefore the horizontal distance covered by B is going to be less than the horizontal distance covered by A. Okay, so as I said, hopefully that makes sense. That's really all this question was. It's quite a nice short question, even though I've made it into almost, I don't know how long this video is. But really it's just, as I said, I threw a bit more information on there. Now, as I said, what I'm going to be doing is I'll be doing a few exam walkthroughs where I'll just be posting online, preferably, I don't know, on Student Room or my personal YouTube page, which is Bill7187 YouTube. Obviously, weirdly enough, it took me a long time to think of that, by the way. I did think of, history weirdo nerd, but I don't think that'd be quite catchy to put in an advert anyway on Facebook. So I'm going to be doing that. But anyway, really, this is, as I said, I'll just be putting online an exam walkthrough to the exams, but I'm going to try and get all these videos done before that. Okay, so thanks for watching, and we'll see you in question 3.